Welcome friends. This is the answers explaining session for task 2. First of all, I will explain the answer for today's question. Okay, I will read the question now. A plastic sleeve of outer radius R naught is equal to 1 mm covers a wire of radius 0.5 mm carrying an electric current. Thermal conductivity of the plastic is 0.15 watt per meter Kelvin. The heat transfer coefficient on the outer surface of the sleeve exposed to air is 25 watt per meter square Kelvin. Due to addition of plastic cover, the heat transfer from the wire to be ambient will be dash. We have to find that whether the heat transfer will increase or remain the same or decrease or be zero. This kind of problem is already discussed in task 1 2. I know, although I am explaining here this type of problem. How to find the answer? First of all, they given the outer radius 1 mm and thermal conductivity 0.15 watt per meter Kelvin and heat transfer coefficient 25 watt per meter square Kelvin. Normally, I have already given you the formula that how to find critical radius or C is equal to K by H. If you find the critical radius, the answer we are getting is 6 mm, which is greater than the outer radius. Therefore, heat transfer will increase. Hence, the option is will increase. That is answer is option A. Okay, now we discuss the answers for yesterday's question. First question, which is from general aptitude. I will read the question. The aircraft dash take off as soon as its flight plan was filled. Option A is allowed to. Option B is will be allowed to. Option C is was allowed to. Option D is has been allowed to. In this question, if you read this question, you itself felt that the given question is in past. Therefore, answers will be too fast. That is, answer should be in past tense. Therefore, here only one option with past tense is option C. Therefore, the answer for this question is was allowed to. Okay, this is the second question, which is from our topic heat and mass transfer. Okay, now I will read the question. A balanced counterflow heat exchanger. You note this? This is a counterflow heat exchanger. Has a surface area of 20 meter square and overall heat transfer coefficient, that is U, capital U, is 20 watt per meter square Kelvin. Then air of specific heat 1000 joules per kg Kelvin entering at 0.4 kg per second, which is mass flow rate, and 280 Kelvin is to be preheated by the air leaving the system at 0.4 kg per second and 300 Kelvin. The outlet temperature of the preheated air is, that is, we have to find the outlet temperature of preheated air. You have to carefully read this question because in this question there is a twist. Okay, I will explain the twist. They told that air entering at 0.4 kg per second and 280 Kelvin is to be preheated. Hence, it will be a cold fluid and its entry temperature is 280 Kelvin. Here there is no confusion. But after this, by the That is, the cold fluid is heated by the air leaving the system at zero point 0.4 kg per second and 300 Kelvin. Here you must carefully read this. Here they given that the cold fluid is heated by the air which is leaving from system. Here the system doesn't represent the heat exchanger. It may be another system. Therefore, the given temperature is inlet temperature of hot fluid. Okay, this is the twist. Now we can solve the answer. Okay, I had personally solved this problem which is in the screen now. First of all, given data, they given surface area and overall heat transfer coefficient. Then I have separated it as hot fluid and cold fluid. Here I striked the TH out, which is the outlet temperature of hot fluid, and I marked as important because here is the twist. Normally we think it as the given temperature is outlet temperature of hot fluid. Hence we have to read carefully and choose and take the given data carefully. Okay, hence they given that given temperature of hot fluid is inlet temperature. Okay, here the mass flow rate for the both the fluid is same, and here they given the specific heat capacity of cold fluid alone. We here we are going to assume that both the fluids specific heat to be that value. Okay, we have to find the TC naught. Then formula we are going to solve by NTU method, which is number of transfer unit method. This is the formulas which we require to solve this problem. Okay, now we go to solution part. First of all, we should find the NTU. Okay, NTU formula is UA by C min. Here C min is the heat capacity rate. Okay, it means m dot into Cp value. We have to find that heat capacity rate for both hot fluid and cold fluid. From this we have to choose the minimum value. Here it is no problem that for the both fluids it will be a same value, hence I have taken it as 400 joule per kg Kelvin. If I substitute this in NTU formula, we get NTU as 1. Now with NTU value and this ratio C min by C max, we are going to take the value of effectiveness from the effectiveness chart in HMT data book, because they will not, I think so, they will not provide that these charts in the examination. Hence we have to remember, it's not a difficult task, it's a simple, we can easily remember that charts too. Okay, if you take the approximate value, it's enough, we will get the answer near to the original answer. Okay, if we take the epsilon value, we are getting effectiveness as 0.5. We have to know that another formula, Q equal to epsilon into Q max, that is Q max. Here I separately wrote the Q max formula. Okay, now we know that, now we substitute here, that is in Q equal to effectiveness into Q max formula. Now we can get easily the outlet temperature of cold fluid. That's it. Hence the main thing is to read the question carefully. Okay, subscribe this channel and click the bell icon to receive daily questions daily, and thank you. I will meet you in task 3.